Hi everyone. In this video, we'll take a look into what is Spring Data JPA. Before understanding Spring Data JPA, let's first understand the underlying problem in persistence layers and how Spring Data JPA simplifies it. Consider we have Spring Boot application architecture over here. This is basically called three-layer architecture. We have controller layer, service layer, and persistence layer. Generally, we use JPA or Hibernate to develop persistence layer. If you use Hibernate to develop persistence layer, then we need to write lot of code. Like we need to write entity manager, we need to write JPQL or SQL queries and implement CUD logics manually like that. By using Spring Data JPA, we can reduce lot of code to develop persistence layer. Let's go to IDE. It is customer repository interface. It is extending JPA repository. The JPA repository is a generic type. See here we are passing customer and integer. Customer is the entity and integer is the primary key data type. Let's go inside this JPA repository. This interface internally extending from list CUD repository and list paging and sorting repository and query by example executor. Let's go inside list paging and sorting repository. This list paging and sorting repository internally extending from paging and sorting repository. Let's go inside this repository. See here, this paging and sorting repository provides two methods. This method is supports for sorting and this find all method is support for pagination like that. And this JPA repository has one implementation class that is open its implementation. See, this is simple JPA repository. Click on that. Simple JPA repository is the class. It is implementing from JPA repository implementation interface. Let's go inside this. This JPA repository implementation interface internally extending from JPA repository like that. The simple JPA repository internally annotated with repository annotation and transactional annotation. Here I am providing repository annotation. Actually, it is optional. Here we are not required to use @repository annotation at this customer repository because this simple JPA repository internally using this annotation. So it is not required now. Let's remove this like this. And this JPA repository provides full CUD operations. Let's go inside this. This is the JPA repository interface. It provides these methods like that. This is how Spring Data JPA provides the solution to reduce lot of amount of code that we need to write in order to develop persistence layer. What is Spring Data JPA? Spring Data JPA is abstraction layer that built on top of JPA that eliminates boilerplate code. See here, whenever we perform save operation or delete operation, how CUD works internally. Consider if we call user repository.save method, then save method internally uses entity manager.persistence method. Then Hibernate generates SQL query and JPA executes that SQL query. Finally, database stores record like that. Derived query methods. Spring Data JPA can generate queries from the method names. For example, find by email, find by greater than, find by status and roles like that. Whenever we declare query methods inside Spring Data JPA repository, then Spring Data JPA automatically provides the implementation and execute the required database operations. Like it parses method name and converts it into JPQL. Then Hibernate converts JPQL to SQL queries like that. See here, what is JPQL queries? JPQL stands for Java Persistence Query Language. Here, JPQL is an object-oriented query language used to query JPA entities, not database tables. It allows us to write database-independent queries using entity objects instead of database tables in Spring Boot application. Here we are using query annotation. By using query annotation, we can provide JPQL queries and native SQL queries. Native SQL query allows us to write actual database specific SQL inside Spring Data JPA repository. That means it uses table names and column names, not entity names and field names, unlike JPQL. To enable native SQL queries, here we need to provide attribute that is native query is equal to true, like that. Entity relationships. Entity relationships also called as ORM mappings. Entity relationships define how JPA entities are connected to each other and map to database tables using foreign keys and giant tables. JPA supports 4 core relationships such as one-to-one mapping, one-to-many mapping, many-to-one, and many-to-many mappings. Here, one-to-one mapping means one record in one table is associated with one record in another table. For example, one user has one profile, one person has one passport, like that. And one-to-many mapping. One-to-many mapping means one parent entity is associated with multiple child entities. For example, one customer can place multiple orders, and one department has multiple employees, like that. And many-to-one mapping. Many-to-one mapping means many entities point to one parent entity. For example, multiple orders belongs to one customer, or multiple employees belongs to one department, like that. And many-to-many mapping. Many-to-many mapping nothing but many records in one table are linked to many records in another table. Here, many-to-many means both sides can have multiple associations with each other. For example, users and roles, and student and course, like that. Here, entity relationships define how Java objects are connected, persisted, and retrieved using foreign keys, giant tables, and ORM rules while maintaining object-oriented design, like that. And fetch types. Mainly fetch type controls data loading strategy, not relationship type. We have two enum constants, that is eager and lazy. Eager means it loaded immediately. That means related entities are fetched immediately along with the parent entity. And we can provide fetch is equal to fetch type dot eager, like that. And second one is lazy, loaded only when accessed. That means related entities are loaded when we accessed. Here we need to provide fetch is equal to fetch type dot lazy. Generally we will use fetch type dot lazy to achieve performance. Cascade types. Cascade defines what happens to child entities when parent changes. Cascade types defines how operations are performed on a parent entity are automatically propagated to its related child entities. And cascade controls entity lifecycle propagation, not data loading. For example, when we save a parent or update the parent, then the same operation applied to its child automatically. We have cascade types such as persist, merge, remove, refresh, detach, and all. Persist means when a parent entity is persisted, all related child entities are also persisted automatically. Merge, update child when parent is updated. That means when a detached parent is updated, then the child entities are also updated. Remove, delete child when parent is deleted. That means when a parent is deleted, then related child entities are also deleted. Next, refresh, reload child from the database. That means reload child entities from the database when the parent is refreshed, like that. Next one is detach. Detach child from persistence context. That means detach child entities when the parent entity is detached. And last one is all. That means it applies all cascade operations. Let's go to STSID. See here, this is enum, that is cascade type. It provides these enum constants. That means all, persist, merge, delete, refresh, and detach, like that. Here, cascade type propagates entity lifecycle operation from parent to child in JPA relationships. Okay, I will see you in the next video.